Hello, friends. My name is Ashmita Divedi. Here I will be presenting you about the B Pharmacy third semester second unit, that is Rheology. So let's start with the topic, and the topic of the second unit of B Pharmacy third semester is Rheology. So what Rheology basically means? Rheo is made up of two words, rheo, that is flow, and logos means science or study. So what will be the definition? The definition will be, it is the branch of science in which we study about the flow. What kind of flow it is talking about? The flow of a liquid or a flow of a fluid. Right? So it will be defined as the science of flow and deformation of material under influence of stress. Right? मतलब कि दिस इज़ द साइंस ऑफ फ्लो, जहाँ पे हम किसी मटेरियल पे स्ट्रेस अप्लाई करने पे, फोर्स अप्लाई करने पे उस मटेरियल के डिफॉर्मेशन की स्टडी करते हैं. दैट इज नोन एज रियोलॉजी. राइट? नाउ दिस रियोलॉजी, हियर वी आर टॉकिंग अबाउट द रियोलॉजी ऑफ अ लिक्विड, ऑफ अ फ्लूइड. दैट्स वाई इट विल बी डिपेंडेंट ऑन द विस्कोसिटी. राइट? नाउ कहाँ यूज़ होता है इन रियोलॉजी का यूज़ कहाँ होता है? सो मैन्युफैक्चरिंग ऑफ डोसेज फॉर्म, इफ़ वी आर प्रिपेयरिंग एनी फॉर्मुलेशन लाइक इमल्शन, सस्पेंशन, these type of formulations, and mixing and flow of material while manufacturing any dosage form. In the mixing and flow of the material, rheology important, and packaging. In packaging also rheology plays important part. Right? Now how many types of flow? We are talking here about the flow of a liquid. So there are two types of flow. Right? What are those? Newtonian flow and non-Newtonian flow. Non-Newtonian and non-Newtonian. What Newtonian and non-Newtonian represents? There is a law that is called as Newton's law, and what that states? Newton law states that the materials which obeys Newton's law of flow are known as Newtonian flow or Newtonian fluid. Right? So basically what Newton's law of flow is, it states that the shear stress is directly proportional to the rate of shear strain. So basically it is represented by tau. Tau represents shear stress is directly proportional to the dV. Here is dV by if we will remove the proportionality constant, it will become tau is equals to eta dV upon dr. So eta represents here viscosity, tau is the shear stress, dV by dr, that is shear strains. Right? So what is basically Newton's law? Is the shear stress is directly proportional to the rate of the shear strain, and shear stress is represented by tau is directly proportional to dV by dr, that is shear strains. So this is the shear stress which is getting applied on a fluid, and this is the shear strain. Shear strain means the deformation of any fluid, and eta is the viscosity. Right? So now we talked about the Newton's law. So the fluids which obeys the Newton's law is known as Newtonian flow. Right? Now there is second, that is non-Newtonian flow. What is non-Newtonian flow? Non-Newtonian means fluids which does not obeys the Newton's law is known as non-Newtonian fluid. Now Newtonian fluid is only of single type, but non-Newtonian fluids are of three types. Those are pseudoplastic flow, plastic flow, and dilatant flow. Right? We'll see them each. Now what is shear stress? Right? Here we talked about the, if we are applying shear stress on some fluid, it will deform. So what is this tau? How we will define this tau? That is shear stress. So it will be defined as the ratio of shear force to the cross sectional area that is required to flow. This means, suppose we have a particular area of a fluid. The fluid is represented by the layers of the liquid. in a fluid, right? So this is ratio of shear force to the cross sectional area required to flow, right? Shear stress tau is equals to force per unit area that is required for this fluid to flow is known as shear stress. This means the force which we are applying on a particular cross sectional area of this liquid to flow, this is known as shear stress. Now rate of shear strain, how we are going to define this dV by dr? So it will be defined as the change in velocity that is dV between two planes of the liquid which is separated by a distance that is dr. So shear strain will be this. What is the Newton's law called? Newton's law is tau is equals to dV upon dr. So this is shear stress tau, and shear strain will be dV upon dr. How it will be defined? It will be defined as the change in the velocity between two planes of liquid which is separated by a distance dr. So it will be shear stress is equals to dV upon dr. So here it is saying like defined as change in the velocity between two planes. So what are these two planes? Two planes are, suppose we have a liquid in any sort of container. These liquids are attached to each other layer by layer. Like this is the topmost layer of the liquid, this is the second layer, third most layer. These are divided by the layers of liquid. So it is talking about two layers, distance between these two layers of a liquid. It states as change in the velocity that is dV between two planes of liquid which is separated by dr distance, right? So these are separated by dr distance and जो change आ रहा है velocity में that is dV. So it will be dV upon dr. I hope समझ में आया होगा ये इतना. Now what is Newton's law? Force per unit area which is required to create a fluidity in any liquid, that is dV upon dr. If we will remove the proportionality constant, here eta will come, which represents the velocity, right? Okay, so there is a curve for Newton's law, curve for Newtonian fluid. What are Newtonian fluids? The fluids which obeys the Newton's law are known as Newtonian fluid, right? So if we will make the graph between the shear stress, that is force per unit area which is required to flow, right, versus rate of shear strain on x-axis, that is dV by dr. So if any fluid will follow the Newton's law, the graph between shear stress and shear strain will come a straight line. Let's say for water. Why? Suppose there is a water, right? If we will apply a particular amount of force in this water to flow, this will follow Newton's law. This will flow easily when we will apply a particular amount of stress on it, shear stress on it, it will flow easily. So that's why this graph will become like a straight line. Graph will be obtained between shear stress and shear strain. Okay, but now if you talk about the non-Newtonian fluid, they will not follow the like straight line. They will not go into straight line. There are three types of non-Newtonian fluid. We talked about it before, right? Non-Newtonian flow are of three types: pseudoplastic, plastic and dilatant. We will talk each one of them separately when we talk about the non-Newtonian fluid, right? So this was all about the Newton's fluid which we just talked, right? Now we'll be getting on the non-Newtonian fluid system. Okay. So what are non-Newtonian system? We just talked about it. The fluid which does not obeys the Newton's law are known as non-Newtonian fluid. ठीक है? Non-Newtonian are those which does not obeys follows the Newton's law of flow. Shear stress and rate of shear is not constant. Here the rate of shear stress and the shear strain both are not constant, right? So types are plastic, pseudoplastic, and third one is dilated. Okay, we'll talk one by one. In Newtonian system, viscosity is not constant. Emulsion, gel, ointment. Okay, we'll talk separately. You will get to understand what are these, what this point means, right? First one is plastic flow. Now, what is plastic flow? Those materials which follows plastic flow is known as Bingham bodies. These are also known as Bingham bodies. The materials which follows plastic flow. Now, what is plastic flow? How they will show the plastic flow? In plastic flow, when we apply shear stress initially, there will be no change in the velocity or viscosity of that particular field until a small amount of yield value will be applied on it. Let's make it easy for you. What is yield value? This means initially, suppose this is the graph of shear stress versus shear strain, right? Here, if we are applying some shear stress, some shear force is applied, there will be no change in the like fluid will not flow until unless a small amount of yield value will be applied on it. I will give you an example for the plastic flow. You must have seen ketchup, tomato ketchup sauce. What happens, suppose if it is in its container, you must have eaten samosa with sauce in canteens and all, so you must have seen the ketchup bottle. What happens when you initially like squeeze the bottle, it easily do not comes out of the bottle until you will not apply a particular amount of force. If you will forcefully squeeze the bottle, then the ketchup will come out of the container and it will get thickened. Initially the ketchup is viscous in the container, but when you apply more than more than yield value, then it will come out, it will flow out easily of the container. So you understood what I want to convey to you. Ketchup is the real life example of the plastic flow. What happens here? Until and unless you will not apply a particular yield value, the ketchup will not come easily off that ketchup bottle. A definite amount of force or yield value will be required for this ketchup to come out of the bottle, and it will become thinner in the bottle. It is in thick form. Once you apply some kind of pressure, it will come out as a thin liquid, right? I hope you must have understood. So what is the plastic flow? Basically, when we apply shear stress initially, there will be no change in the shear strain until shear stress reaches the yield value, right? So what is yield value? The amount of shear stress are required to break the floccules is called as yield value. ये हमारा जो केचप था वो थिक था, राइट? क्या था? थिक था. हमने shear stress अप्लाई किया तो ये इनमें फ्लूइडिटी आएगी और एक यील्ड वैल्यू से जब एक्सीड हो जाएगी तब ये हमारा फ्लो होना स्टार्ट हो जाएगा. सो दिस वाज द यील्ड वैल्यू एंड दिस वाज द कर्व कि दिस रिप्रेजेंट्स यील्ड वैल्यू. Yield value will be required for it to flow. Curve does not passes through origin, and this curve will not pass through the origin because this is not Newtonian fluid. This is plastic flow, right? Now mathematically, if we talk about the shear stress is directly proportional to shear strain, mathematically it will be capital F minus small f is directly proportional to G. So G here represent rate of shear, amount of force, right? Here capital F is shear stress, right? Minus F is the yield value. shear stress में से हम yield value है ये directly proportional to G. G हमारा हो गया rate of shear, capital F minus small f, shear stress minus हमारा yield value. Now if we will remove the proportionality constant, it will become Mu is the plastic viscosity. So mu represents plastic viscosity. It will be capital F minus small f upon G. So this will be the final equation for plastic flow, right? Now example of these are flocculated systems, suspensions of zinc oxides in mineral oil. These are the examples of plastic flow, right? So this was the mathematical expressions of the plastic flow, right? I hope you must have understood something. This was the first lecture for today. We'll discuss about the pseudoplastic flow and dilatant flow in the next lecture. If you have not got anything, if you have not understood anything, you can ask me in the comment section. There will be comment section. You can ask me if you want, and if you like the video, please share, subscribe and like the video. Thank you so much, friends.